Hello everyone, welcome to Dr. Ravi's Academy. In today's class, you will be learning how to draw the velocity diagram and in turn how to calculate the angular velocity of the output link RS. Let us look at the problem. The dimensions of all the links are given and the angle also it is given. Now, look at the dimension fixed link PS, that is 200 mm. It is 200 mm is too long to draw the diagram. For that purpose, what you have to do is you have to adapt a scale. So I am adapting a scale of 1:2. That means the given length divided by 2 I am taking and draw the configuration diagram to the scale. So that is your first step. Draw a link of fixed link PS. 200 is given, you take it as 100 mm length. This is your fixed link PS. Rectal line at an angle 60 degrees and the length is given 62.5. Mark it as 31.25 so that you are going to get your point Q on this, and QI center 175 divided by 2, that is 87.5 mm is radius. Draw a circular arc, and 112.5 by 2, that is 56.25 as radius. Cut this so that you are going to complete the configuration diagram to the scale. It is 56.25 and this is 87.5 and this is of course 100 mm fixed link. So this is very first step. Complete the configuration diagram to the scale, and this you have to ensure that you will be going to accommodate the diagram in A4 size paper. So after this, calculate the velocity of the input link, that is PQ. So velocity of Q with respect to P is R omega. R is nothing but length, that is 62.5 mm. 62.5 divided by 1000, that is in meters, into angular velocity 10, which is given. So this gives you 0.625 meters per second, and to draw this you have to adapt a scale. I am adapting a scale for the velocity diagram as 1 centimeter 1 unit is equals to 0.1 meters per second. With this, your velocity of QP will be how much it is? It becomes 6.25 centimeters length. The direction is known. It is perpendicular to the line joining QP. So this is the direction of velocity of Q with respect to P. So let us draw a vector whose length is 6.25 centimeters and beginning point is pole, that is fixed point P, as well as S, and the other end is Q. This length is 6.25 centimeters. This particular vector is completely defined. Now let us see the direction of the velocity of this R with respect to S. The direction is known. Draw the direction of this, and the direction of R with respect to Q, it is perpendicular to it. So passing through Q perpendicular to it, so that the intersecting point is your required point R, and you have completed the velocity diagram, and your required velocity is RS. This is what is SR. It is, if you measure this length, you are going to get 4.25 units centimeters of length, and this length is required. Let us calculate the velocity of R with respect to S is, it is 4.25 centimeters length into scale factor is 0.1, so that you will get it is 0.425 meters per second is the velocity. Now you can calculate angular velocity, that is omega of Rs, which is equals to Vrs divided by Rs length. So it is 0.425 divided by Rs is your 112.5 in meters, it is 1125, and this gives you 3.8 radians per second. This is the required answer, that is angular velocity of your output link. I think you understood this procedure, and let us proceed to practice this particular problem.